Hello there, mathematicians! Today we're going to give examples on how to add polynomials. Okay, let's go to example number 1. 3y plus 2y. Okay, the very first thing that you're going to ask yourself is, are the two terms like? Yes, they are, because they have the same variable y. And since they are like terms, we can now add the two terms together. Okay, let's start. Since they are similar, we're going to separate the numerical coefficients 3 and 2 and copy their operation plus and copy the like variable y. And then you add the numerical coefficients 3 plus 2. Yes, you are right. It's 5. So the answer is 5y. And always remember to box your final answer. And we are done. And that is the answer. We are done with that. Okay, now let's move on to example number 2. 3u cubed plus negative 9u cubed. Okay, we're going to check if the two terms have like terms. Yes, they are, because they have the same variable u cubed. Okay, now let's start solving. We're going to write 3 and negative 9 together. So I'm going to use braces because I'm going to use parentheses to separate negative 9. And then write u cubed. In this manner, we're going to solve 3 plus negative 9. Yes, your answer should be negative 6u cubed. And then, always box your final answer. We are now in example number 3. 2a minus 1 plus 4a plus 3. I would recommend, class, that you're going to rearrange the terms in such a way terms with like variables are written beside each other, like 2a plus 4a plus negative 1 plus 3. In this manner, it is easier for us to add the polynomials. Okay, so as I've said, separate the numerical coefficients 2 and 4. Then copy variable a. Please simplify negative 1 plus 3. The answer is 2. And lastly, 2 plus 4 is 6, right? 6a plus 2. And that's it. That is now the final answer. Thank you so much for listening. And that's all for adding polynomials. Hi, hello there again, mathematicians. Now we are going to discuss for today subtracting polynomials. Subtracting and adding polynomials has similar rules, but in subtracting polynomials we have an additional step. Please be guided accordingly. So let's get started with example number 1. 2w minus 5w. Okay, this is the very first thing you're going to do. Copy the minuend 2w, change the operation to addition, and get the opposite side of the subtrahend, which is negative 5w, and proceed to the rules of addition. Again, separate the numerical coefficients 2 and negative 5, and copy the like variable w. 2 plus negative 5 is, yes, you're right, that's negative 3, copy w. And that is now your answer. Now let's move on to example number 2. Okay, as I have said in example number 1, we will copy the minuend negative 4 x squared y, change the operation to addition, and get the opposite sign of the subtrahend, negative 2 y squared y. Okay, this time proceed to the rules of adding polynomials. Separate the numerical coefficients negative 4 and negative 2 and copy the same variables x squared y. Then simplify. Negative 4 plus negative 2 is, yes, negative 6, copy x squared y. Then, again, box to highlight your answer. Let's continue to example number 3. 2a plus 4b minus 5a plus 3b. Okay, before anything else, change the sign first. 2a plus 4b plus, get the opposite sign of the subtrahend, negative 5a minus 3b. Afterwards, I want you to rearrange the terms in such a way same terms will be written together with each other. So, that's 2a minus 5a plus negative 3b plus 4b. Okay, now let's start. Okay, separate the numerical coefficients, that is 2 minus 5 and copy a, plus separate the numerical coefficients again, that is negative 3 plus 4, copy b. Then simplify. 2 minus 5 is, yes, negative 3a plus negative 3 plus 4 is 1, and you may not write any more 1 and just write b because it's already understood that there is an imaginary 1 beside b here. And that's it. That is now your final answer. That's all for now for subtracting polynomials. Thank you. Now let's move on to our next topic, multiplying polynomials. In multiplying polynomials, it's very important that we have mastered the laws of exponent because we're going to use the concept of laws of exponent in multiplying the different variables in the polynomials. So let's get started on example number 1. Negative 3m squared n cubed multiplied to 5mn squared. So in multiplying polynomials, we're going to multiply or simplify the numerical coefficients, then multiply the literal coefficients and simplify the answer if needed. So in this case, the numerical coefficients are negative 3 and positive 5. So we will multiply them together, we will separate them, and same variables, m squared times m, and another one, n cubed times n squared. So basically, class, we're going to just write the same variables together so that it's easier for us. So we will multiply negative 3 times 5, that is negative 15. And that is m squared times m, that is m. So we're going to add their exponent. And this also for n, 3 plus 2. In this case, we're going to simplify. So negative 15 m cubed n to the 5th. And that is now the answer for multiplying monomial times monomial. Okay, now let's move on to the next example. Okay, for the example number 2, we're going to multiply monomial times trinomial. Okay, in this manner, we are going to use the distributive property of equality, wherein we're going to distribute 2x to the terms inside the parenthesis. Okay, so it will become 2x times x squared, copy minus 2x times 4x and 2x times 3. Okay, now multiply 2 times the imaginary 1 here. So basically it's also still 2. 2, there is an imaginary exponent of 1. So 1 plus 2, we're going to add them. So it will become cube minus 2 times 4, that is 8. 8x squared, because you're going to add the 2 imaginary exponent of 1. Then lastly, 2 times 3, that is 6. Copy x. And that is now the answer for multiplying monomial times trinomial. Basically, if you're going to multiply monomial times binomial, you will have the same process. Okay, now let's move on to our third example. This is binomial multiplied to binomial. 2w plus 3 multiplied to 5w plus 4. So, in this one, we're going to use the very famous FOIL method. FOIL means first, outer, inner, and last terms. Okay, now let's identify. What are the first terms of each binomial? So the first terms are 2w times 5w. So that is the first terms. Now let's have the outer terms. The outer terms are 2w and 4 plus the inner terms are 3 times 5w. Then the last terms are 3 times 4. So let's try to check. This is the first terms, outer terms, inner terms, and last terms. Okay, now let's simplify the expression. 5w times 2w, that is 10w squared, plus 2 times 4, that is 8w, plus 3 times 5, that is 15w, plus 12. This time, you are going to simplify the expression and combine like terms. And the like terms here are 8w and 15w. So you're going to add them together. So it will become 10w squared plus 23w plus 12. And that is now our answer. Okay, that's all for now. Thank you. Okay, now let's move on in discussing dividing polynomials. Okay, number 1. 12m to the 7th divided by 4m cubed. In dividing monomials, write the given in fraction form first. So this given is not yet in fraction form. So we will write or rewrite this one in fraction form. So it will become 12m to the 7th divided by 4m cubed. In this way, it is easier for us to divide the monomials. Then simplify the numerical coefficients. The numerical coefficients 12 divided by 4 is 3. Yes, you're right. Then, based on the loss of exponent, you will subtract the exponents. 7 minus 3. So 7 minus 3 is, yes, m to the 4th, and that is now our answer. 3m to the 4th. Now let's move on to example number 2. 18m minus 24 divided by 2. So for us to have an easier division process, we will separate the two terms and divide each term by 2, like this. 18m divided by 2 minus 24 divided by 2. Then, divide each term by 2. By 2 is 9 copy m minus 24 divided by 2 is 12. Right, you're correct. Then, box your final answer. And that's it. Now, example number 3. 3a to the 5th minus 5a cubed plus 2a squared all over a squared. So we will separate first. Each term and divide it by a squared. So 3a to the 5th divided by a squared minus 5a cubed divided by a squared plus 2a squared divided by a squared. Okay. By loss of exponent, we're going to subtract 5 minus 2. Okay. 5a 3 minus 2 plus 2 minus 2. So simplify. 5 minus 2 is 3 minus 5a. 3 minus 2 is 1, so you may not write 1 because it is already understood that there is an imaginary 1 above a. Now let's proceed to the next term. 2a to the power of 0. Okay, according to the laws of exponent, any base raised to the power of 0, the answer is, yes, 1. So it will be 2 times 1, that is 2. So your final answer is 3a cubed minus 5a plus 2. That's all for division of polynomials. Thank you.